welcome to the Chapter 11 Part 1 video. Chapter 11 will actually be 3 parts instead of the normal 2. This part covers 11.2 and 11.3, and we'll be talking about surface area. Our first section is surface area of prisms and cylinders, and our objective is to be able to find the surface area of those shapes, specifically prisms and cylinders. So before we can talk about defining a prism and a cylinder, we need to go back and recall the difference between our different dimensions. So remember, we had a point that has 0 dimensions, a line has 1 dimension, and then we have all of our other flat shapes, which are 2-dimensional. So a square, a rectangle, parallelogram, all of those are 2-dimensional shapes. So for example, a circle is a 2-dimensional shape. If we take that circle and we make it 3-dimensional, meaning we're viewing it in an additional set of space, we can have shapes like a cylinder, which is a circle that has depth, a cone, which is a circle that has depth but to just a point instead of to another circle, and then we have a sphere, which is like if I take a circle and I were to rotate it. So all 3 of these shapes are 3-dimensional circles, so to speak. Okay, so now we can say specifically that a prism is a 3-dimensional figure whose surfaces are polygons. Okay, so let's look at a couple of examples of prisms. We have a prism here that has 2 triangles and all of the rest of the sides are rectangles. Because the 2 sides that are triangles are parallel, right? If I were to cut this into pieces, these are the 2 sides that would be cut parallel to each other. This is called a triangular prism, because I have these 2 triangles. And then we have this prism where all of the sides are rectangles, and so this is a rectangular prism. What's special about rectangular prisms is that I could choose these 2 sides to be the bases, the parallel sides. I could choose the front and back, or I can choose the top and bottom, and all 3 of those pairs make parallel sides. And then we have a cylinder, which is a little bit special because it's harder to see the rectangular side, but really if we were to cut this cylinder down the side and open it up, as we saw in the activity this morning, that wrapping around shape is a rectangle. And so a circular prism, where we have the bases as circles, is called a cylinder. Same as a circular prism. Now, we never use the term circular prism. That's just not used because it has the name cylinder. So a circular prism is called a cylinder. A prism is a polyhedron, meaning multiple sides, 3-dimensional multiple sides. It has 2 congruent parallel faces. These are called the bases. So just like we had for our 2-dimensional figures, we had a side that we considered the base. These 3-dimensional figures will have a 2-dimensional side, so it will have a shape that is its base. The other faces are called lateral faces. Lateral means side. So essentially we have the bases and we have the sides. And the lateral faces are always quadrilaterals. So the cylinder is a solid that has 2 congruent parallel bases that are circles, and I'm going to put and 1 rectangular side. And the bases are, for a cylinder, it's the circular parts. For the prism, we choose the bases that are congruent and parallel. Sometimes we have a choice. We could choose different bases. We could choose, for example, for the rectangular prism, we got to choose which 2 are our bases. Sometimes there's no choice. There's only 1 option for a triangular prism. The height of the solid is the distance from base to base. So if we're looking at these diagrams, the distance from one base to another base is the height. Now, because those 2 sides are parallel, no matter where we go between these 2 sides should have the same height. So any of these distances should be the same between the 2 sides. So all of these should have the same height if I choose the right side or the left side. If I choose the top, the bottom, the back, the left, the right, the top. They should all have the same height no matter which side I measure from. And just like for our 2-dimensional figure, The object that we're using to measure the height is called the altitude. So the altitude of the prism is the perpendicular segment that joins both bases. So if we look at these shapes in this first example, we want to shade the bases and label the height. That's all we're going to do first. We're just going to find the bases. If I'm looking at this first shape, I need to find the two sides that are parallel and congruent. And a good way to do that is to find non-rectangular or non-quadrilateral sides. So here I have a pentagon. That's going to be one of the bases. And the other base is this other pentagon. And the height has to connect those two bases. So I can choose any of these segments that goes between those two bases to be the height. In our next one, we're looking again for two congruent parallel sides. We have some options here, but we also want to be able to find a height. So we want a pair of sides that has an altitude between them. So I'm going to say, well, here's the only labeled right angle. So this is going to give me the height, just the vertical part. Okay, this bottom part is just to show that it's perpendicular. That distance, that length doesn't represent anything that we're using to calculate. And so what two sides does that height measure between? It measures between this side and this side. So those would be considered our two bases if we are using this height. For the next example, we have a cylinder. So again, looking for the non-rectangular side, we have the circle on the top and the circle on the bottom. The height can be any distance between those two sides. So that can be our height. And then our last example, looking for the two sides that are not quadrilaterals. We have a triangle here and a triangle here. And the height is the distance between those two sides. And so I can choose any of the segments that connects those two sides. Let's take a look at a few more examples. So in this page, we're doing something similar. We're still shading the bases and we're labeling the height, but now we're going one step further to name the solid. Let's just choose the ones that are at the bottom and the top. And that way we can say, because of all the markings on that bottom shape, we know that they're right angles with four congruent sides. That makes it a square. So we name the shape based on its base. Here's the height between the two bases. Since one of the bases is a square, we know the other one is also a square. So this is a square prism. In our next example, our non-rectangular sides are circles. So this will be a circular prism, which is called a cylinder. So there are my two bases. Choose one of them to be your height. And this is a cylinder. Again, we don't use the term circular prism, but that's really what it is. And number 3, our non-rectangular sides are these two, and those are triangles. And so these two shapes, or this shape is a triangular prism. The height can be between any of the lengths between those two sides. So it could be this one, you could choose this one. Choose one that it's easy to label. If I were to choose the one in the back, that goes through a side that I just colored in, so it's hard to label. So don't choose one that's hard to label. Okay, so now that we have an idea of what these shapes are, let's see what we can use them for. And if you'll remember our activity from this morning, we really focused on looking at the nets of our three-dimensional figure, which was what happens when we look at those figures if they're unfolded, if they're flat on the table. And what we could do is we could find the area of those shapes. Well, when we fold them up, because now they're three-dimensional, instead of saying area, we call it surface area. And before we can find the formula for surface area, we're going to look at just part of the formula that we'll use, which is called lateral area. So we're building up to the point where we can find the surface area of these figures. And so we're going to start with what's called the lateral area. Again, lateral meaning the sides. So we're finding area of the sides. Okay, so this part, the lateral area, does not include the bases. It does not include bases. Okay, so let's see if we can label these. I'm going to call this side my height. We'll call this side my width, and we'll call this side my depth. So we've got a height, a width, and a depth. Using variables to represent the lengths, come up with a formula to represent the lateral area for the prisms. And we're going to use this as our example. So in order to find this area, we're going to find the area of each side. So if I look at the side that I just lightly colored in, that would be h times w, height times depth. The next one is height times width, plus this one will be height times depth again, plus this one will be height times width again. And if we simplify that, notice each of these is multiplied by the height. So let's factor that out. Height times depth plus width plus depth plus width. Well, depth plus width plus depth plus width is the perimeter. Height times perimeter. Now this should look familiar, right? This is very similar to our surface area for regular polygons. And there's a reason for that. Because if I were to unfold this shape back into its net, if I were to cut open the sides and fold it flat, then what this would make is just one giant rectangle. And so this is actually the same as the area of a rectangle. But we're going to say this is our formula for lateral area. So lateral area equals the height times the perimeter. Usually we do perimeter first, perimeter times height. But because it's multiplication, it doesn't matter which order you write it in. Where P is perimeter and H is height. So if I wanted to find the lateral area for this rectangular prism, I would say the height is 5. The perimeter is 4 plus 3 plus 4 plus 3, which is 14. The lateral area is 5 times 14, which is 70 squared centimeters. Again, squared because this is 2 dimensions. When we're coloring in our shapes, we're coloring in 2-dimensional space. I'm not filling in the space between the sides. We'll get to that in a future video. So let's look at these examples. Find the lateral area of the prism. So we have this length here is 5, this one here is 5 and 6, and that makes up one of our bases. Here's our other base. So that makes this the height. We want to find the lateral area, which is perimeter times height. And when we say perimeter, it's the perimeter of a base, of one of our bases. So if I want to find the perimeter, if I start in one corner, that's 5 plus 5 plus 6. I ended back in the same corner. So that is 16. My perimeter is 16. My height is 12. 16 times 12 gives us a total of 224. My units are centimeters. This is an area, so it's squared. Okay, so using that formula to find the perimeter of one of the bases times the height, which is the distance between the two bases. We'll do the same thing for number 2. Again, I'm going to say these are my bases, my non-rectangular sides. So to find lateral area, we need a perimeter and a height. Here's my height. To find perimeter, I need to be able to add up all the sides. Well, I have 3, 4, and I don't know that last side. If you recognize it as a Pythagorean triple, you'll know that that side is 5. If you don't know the Pythagorean triples, then we need to calculate that by using the Pythagorean theorem. So we can say 3 squared plus 4 squared equals x squared, which is 9 plus 16. X squared is 25. If x squared is 25, then x is 5. So our perimeter, 3 plus 4 plus 5 is 12. So our lateral area is 12 plus times 6, not plus. 12 times 6, which is 72 square centimeters. Okay, so that's lateral area, meaning we're finding just the area of the rectangles that go around the sides. In order to find surface area from that, we have to add in the area of the bases. And so that's our formula for surface area. To find the surface area, this is now including the bases. That's the difference between lateral area, which is just the sides, and surface area, which is the whole thing. So to find the surface area, we're going to use the same shape as before. If I call these my bases, this is my height. We can call this a width, and we can call this a depth. So to find our surface area, we're going to take the lateral area, and then we have to add in the area of my first base, plus also the area of my second base. So this is lateral area plus 2 bases. Okay, so our formula here, surface area equals lateral area plus 2 bases. LA is lateral area, and B is base area. Okay, so if I'm talking about, for example, when I'm calculating the area of a triangle, I'll use little b to represent the base of a triangle. Capital B represents the base of a 3-dimensional object. So capital B is an area, little b will be a distance. B is base of triangle, which is a distance, not an area. Okay. So if I wanted to find the surface area of this rectangular prism here, we have the lateral area from above. So surface area would be the lateral area from above, which was 70, plus 2 times the bases. Now each base, this is 4 by 3, this will also be 4 by 3. Area for a rectangle, just multiply the 2 dimensions. 4 times 3 is 12, times 2 is 24, so that's 70 plus 24 equals 94. This is an area, so it's centimeters squared. Let's look at some examples. On our first example here, we want to find the surface area. Make sure you're reading the instructions carefully. In order to find the surface area equals lateral area plus, how many bases do I have? I have 2 bases. So I need to find the lateral area, which is perimeter times height. Now the reason I do these as separate steps is because if I try to do them all in one equation, there's more likely a chance that I'll make a mistake because I'm trying to keep track of too many things at once. If I do them separately, it's going to be a little bit easier to keep track of everything. So here I'm going to say perimeter, 5 plus 5 plus 6. 5 plus 5 plus 6 is 16. Height is the distance between my bases, so I'm going to identify my bases and say this one is my height. 16 times 12 is 192 squared centimeters. And then we also need our bases. So the area of a base, now this is a triangle, and I need to know if this triangle is a right triangle or not. Now I don't know that. I do know that this is an isosceles triangle, right? Because I've got the 5 and the 5. So in order to calculate the base, we need to calculate the area of this triangle. If this is an isosceles triangle, then I can say that the altitude bisects the base. So I have a 3 and a 5. I need to use Pythagorean theorem or know my Pythagorean triples to find this. Now we just did this earlier. Remember we had a 3, 4, 5 right triangle. It's the same triangle here, 3, 4, 5. You can also find that by using Pythagorean theorem. I can say 3 squared plus what squared is 5 squared, and you'll find that it's 4. Now, I can't just say 5 times 5 because those are not perpendicular lengths. So this will be my base, and this will be my triangle's height. To calculate the area of one base, I use 1/2 base times height for the area of a triangle. That's 1/2 little b, base of the triangle is 6, h height of the triangle is 4. And that should give us 12 squared centimeters. And now I'm going to use those and substitute them into my surface area formula. So surface area equals lateral area, 192, plus 2 times, because I've got 2 bases here, 12 for the area of those triangles. 192 plus 24 equals 216 square centimeters for area. And that is our final answer. Okay, let's try another one, same thing. We're gonna go through the steps together. So I need to find the surface area. Surface area equals lateral area plus I have two bases. Color in those bases. This is nice because now we have a right angle, so we won't have to calculate the height of our triangle. Starting with lateral area, perimeter times height. To find the perimeter of this triangle, again, we have 3, 4. This is our magical Pythagorean triple. 3, 4, 5. It's worth knowing. 5 centimeters there. Again, if you don't have it, if you don't remember that Pythagorean triple, you can use the Pythagorean theorem. 3, 4, 5. So our perimeter, 3 plus 4 plus 5. 7 plus 5 is 12. 12 times our height is 6. And so we have 12 times 6 gives us 72 square centimeters. That is the lateral area. Then we also need a base. 1/2 base of the triangle times height of the triangle. Luckily, we have these two perpendicular distances, so I can call either one the base and the other one the height. So that's 1/2 times 3 times 4 is 6 squared centimeters for the base. Surface area is lateral area plus 2 times the area of our bases, which were triangles for this one. So that's 72 plus 12 gives us 84 squared centimeters. Okay. Now, what if our base is not a triangle or a rectangle? Then we have to think about what if it's a circle. So, and it could be any polygon. We know all of the areas from our last chapter for areas of a polygon, and we can use those for any prisms with a regular polygon as its base. So we'll look at the special case of the circle. If we're looking at a circle as our base, we have to remember how to find the area of a circle. And remember, area is pi r squared, not 2 pi r, that is circumference, is 2 pi r. So if I want to find the area of the circle, I need its radius. And the other mistake that's commonly made is this is called its diameter, and the diameter is 2 times the radius. So in this example, I'd like you to try finding the areas of these two circles, and then I'll go through them together with you. In part A, area equals pi r squared. My radius is 3. Pi times 3 squared is 9 pi square yards. This does not give me any instructions to round. It says give me the answer in terms of pi, so we leave it in terms of pi. For B, we're given that the diameter is 2/3 inches. We need half of that for the radius. Half of 2/3 is 1/3. Area equals pi r squared. Pi times 1/3 squared. 1/3 times 1/3 is pi times 1/9, or pi over 9. Units here are square inches. Okay, so using that information, we can find now the lateral area and surface area for a cylinder. So let's start with lateral area. Remember, this is the side area, no bases. So as we saw in our demonstration this morning, to find the lateral area of a cylinder, that's like before we put it into the three-dimensional space, when it was still 2 dimensions, when it was still a flat net, we saw that the shape between the two ends of a cylinder is actually a rectangle. And so we can find the circumference. Circumference is 2 pi r, and that's going to give us the long, usually long length of the cylinder, the length that goes around the circle. And then the height comes from the distance between the two circles. So our area for lateral area, it used to be perimeter times height. Well, now it's still perimeter times height, but the perimeter is specifically a circumference. So circumference times height is 2 pi r h. So for a cylinder, Our lateral area will always be 2 pi RH. But notice, it's the same formula as before. This is just a little bit simplified for the specific case that the base is a circle, where R is the radius of a base and H is the height between bases. Let's look at the formula for what about surface area? So surface area is when we're actually adding the bases in. So this is going to be still the lateral area plus 2 bases, but now our lateral area is specific to a circle. So if we're looking at our shape, a cylindrical shape, we have the height is 5, the radius is 3. So we can say the surface area is lateral area plus 2 bases. Same formula as before, 1, 2 bases, same formula. But we can simplify it. Lateral area will always be 2 pi RH because a cylinder always has the same shaped base, plus 2 times our base will always be pi r squared because it's a circle. So if I substitute the values that we have here, that would be 2 pi times 3, height is 5, plus 2 pi, our radius is 3 squared. So that's 30 pi plus 9 times 2 is 18 pi, giving us 48 pi. Units are centimeters. It's still an area, so it is squared. Okay, so as simple as substituting in those values and formulas that we know from last chapter and the values given. So surface area of a cylinder, 2 pi r h plus 2 base, or we can even simplify it 2 pi RH plus 2 pi r squared, where r is the radius, h is the height, and b is the area of a circular base. So let's see some examples. So example 1, we have a cylinder. Cylinder meaning that my base is a circle. Between the bases is 12 meters. That means that's my height. All the way across one of my bases is 10. That's a diameter, meaning the radius is 5 meters. So first, let's find lateral area. Then we'll find surface area, and we will leave our answers exact. Lateral area, that's perimeter times height, which is 2 pi RH. Radius is 5. 2 pi times 5. Height is 12. 2 times 5 is 10, times 12 is 120 pi meters squared. That is the lateral area. We also need the base in order to find our surface area. Base, these are circles, so that is pi r squared. Our radius is 5, so that gives us 25 pi. Now we have everything we need to find our surface area, which is the lateral area plus 2 bases, 1, 2 bases. So that's 120 pi plus 2 times 25 pi. Don't forget that 2. We have 2 bases we have to find the area of. That's 120 pi plus 50 pi, leaving us with 170 pi units are squared meters. For the next example, we need to draw the picture. The radius of the base of a cylinder, circle, lines that go straight down, circle, we usually do the backside dotted so that we can tell that it's behind. We can't really see the backside of the bottom of the can. Think about like if you're looking at a cylinder, like a jar of Pringles or a salt and pepper shaker or something like that, you can't really see the bottom ring. Okay, so we know the radius of the base is 4. The radius of the base is 4 inches. Its height is 6 inches. What are the lateral surface area and lateral and surface areas in terms of pi? So we need the lateral area perimeter times height, or 2 pi RH. We know our radius is 4 and our height is 6. So that gives us 2 times 4 is 8. 8 times 6 is 48 pi square inches. We also need the area of each base. These bases are circles. And so that is pi r squared. R is still 4. So that gives us 16 pi squared inches. I'm not boxing it because it's not one of the answers that it asked us for, right? It wants our answers to be the lateral area and the surface area. That's the only reason I'm not boxing that. Surface area is lateral area plus how many bases do I have? 1, 2 bases. So our lateral area is 48 pi, 2 bases, which are 16 pi each. So that's 48 pi plus 32 pi, leaving us with 80 pi square inches. 80. Okay. I'd like you to try number 3 and 4, and we'll go through them together. Number 3, this is a rectangular prism. We can't say it's a square because notice our side lengths are not all the same. So this is a rectangular prism. Same process as a cylinder or a triangular prism. We need the lateral area, which is perimeter times height. Perimeter, if I call these my bases, is going to be 5 plus 4 plus 5 plus 4, which is 18. That leaves this is the height. 18 times 5 is 90 square inches. That is our lateral area. We also need the area of our bases. Because this is a rectangle, that's base times height, which is 5 times 4, which is 20 square inches, leaving us ready to find our surface area. Lateral area plus how many bases? 1, 2. 2 bases. Our lateral area is 90 plus 2 times our bases are 20 each. 90 plus 40 equals 130 square inches. And for the triangular prism, this is a right angle. That's nice. I can call this my base and height of the triangle. This is the height of the prism. We do also need this length in order to find the perimeter. But if this is a right angle and this is an isosceles right triangle always has to be 45, 45. So that means that this is 7 times the square root of 2 feet. So our perimeter, 7 plus 7 plus 7 times the square root of 2 is 14 plus 7 times the square root of 2. These are like terms, no radical. This one can't be added because it has a square root. Remember, when we add square roots, treat the square root like an x. If I had 7 plus 7 plus 7x, I can't combine the 7x. It's not a like term. Be careful with that. So our lateral area, perimeter times height, perimeter is 14 plus 7 times the square root of 2. In parentheses, because we're going to multiply that whole thing by our height of 6. 14 times 6 is 84. 7 times 6 is 42 root 2. That whole thing is in feet squared, square feet. We're going to leave that answer exact. If we want to estimate it, you could put it into the calculator, but since it says to leave our answers in terms of pi, we're going to leave all of our answers exact. We have our lateral area. We also need a base in order to calculate our surface area. The base here is a triangle. To find the area of a triangle is 1/2 base of the triangle times height of the triangle. 1/2 7 times 7, in our case, is 49/2 square feet. Now I'm going to leave that as a fraction because I know when I calculate surface area, I'm going to double it anyway. Surface area is lateral area plus 2 times the bases. Lateral area was 84 plus 42 times the square root of 2 plus 2 times 49/2. And this is why I left it as a fraction. I can go ahead and cancel those out. So that's 84 plus 42 times the square root of 2 plus 49. Like terms are the ones without the radicals in this case. 84 plus 49 is 133 plus 42 times the square root of 2. That whole thing is in square feet. Again, that's the exact version. You can put that whole thing in your calculator, 133 plus 42 times the square root of 2, to find the estimated answer. Let's look at our last couple of examples. Okay, this last one we'll go ahead and do together. It is, again, a triangular prism. So my bases are triangles. Now this is a right triangle. However, I'm missing one of the bases that I need, right? I need the two perpendicular sides and I don't have the second one. Well, if you look closely, this is again a 3, 4, 5 triangle. 5 is my hypotenuse, 4 is a leg, then my other leg has to be 3. Again, it is so helpful to know those Pythagorean triples, but if you don't, you can always use Pythagorean theorem. That makes this our height. Perimeter, 4 plus 3 plus 5 is still 12. So our lateral area, perimeter times height, 12 times 8, which is 96 square inches. Area of a base, 1/2 base of the triangle times height of the triangle. That is 4 times 3, giving us 6 square inches. And surface area, which is lateral area, plus 2 times the 2 bases, 2 bases. That's 96 plus 2 times 6. 96 plus 12 equals 108 square inches. Surface area, lateral area. Okay, let's take a look at section 3. In section 2, we looked at prisms. Now, we also said a three-dimensional shape could be a pyramid, right? We said it could have those two parallel bases. We also said it could go to a point. This is a different type of a three-dimensional shape. So a pyramid, instead of going to a second base, just goes to a single point. Now, we also have, just like we had cylinders as a special type of prism, a cone is a special type of pyramid. So I would say that this base, one base here, is a rectangle, then this is a rectangular pyramid. Think about like the pyramids of Egypt kind of had this shape, right? And then this is a cone, so a circular pyramid, but we never use that term. We always call a circular pyramid a cone, which is like a circular pyramid. But again, we don't use that terminology. Circular pyramid doesn't, it's a cone. We use cone as the special name for a circular pyramid. So just like before, we have bases, but this time each of our shapes has only one base. So the base on a cone is the circular part. The base on a pyramid is the non-congruent face that is not coplanar with the vertex. What does that mean? It means the one that doesn't share the vertex where all of the other sides converge. So we're looking for the side that does not have a vertex. Notice this side, the 2 points are separate. On this side, everything goes off to the same point. So we're looking for the side that doesn't have that point of convergence. Okay, in these pyramids, the base is non-congruent and non-coplanar with the vertex. It also has congruent lateral faces that are triangles. So we're looking at regular pyramids, meaning that the sides are always going to be the same. Okay, and we name it by the shape of the base, just like we did for prisms. For heights, we have 2 different types of heights for these. So we have the height that goes straight down from the vertex to the side. That's our normal type of height. It's a perpendicular height. So the distance from the vertex to the base is the height. We also have a second type of height, and that is if I were to slide down the outside of a pyramid, if I were to like be on the top of the pyramid and I slide down on the outside, that is called the slant height. Notice it's slanted from the ground. If this is the ground, that's at an angle to the ground, right? And the slant height with the height create a right triangle. And we will have to use that sometimes to find one or the other. Okay, so the slant height is the length of the altitude of the lateral face of the pyramid. So along the side of the pyramid. So here we have our lateral height. Here would be our height. Okay, so let's look at some formulas. For the lateral area for a pyramid, we have 1/2 pH. Now think about the sides are now made out of triangles instead of rectangles. That's where the 1/2 comes from. P, still for perimeter. L is the slant height. So it's the height of the triangle. Okay, for a cone, 1/2 2 pi r, which is the perimeter, times L, which is again the slant height. For surface area, we're still taking the lateral area, plus now we have only one base. So very similar to what we were doing just before, except that now we have one base, and that base is at a slant. Okay, surface area equals lateral area plus number of bases times the base area. That's the same. Something that's different, lateral area equals pH versus lateral area equals 1/2 PL. So this is height, this is 1/2 slant height. They both have perimeter, but they use different heights. If we compared pyramids to prisms, then we can compare a circular pyramid called a cone to the circular prism called a cylinder. What they have in common, they're both going to use pi in terms of pi is how they're going to be similar. Okay, something that makes them different is, again, for the cone, there's going to be that 1/2 PL, whereas for the cylinder, it's just pH. The perimeters are still C equals 2 pi r, but again, we have that difference between the 1/2 and the L and the H. So very, very similar to the similarities and differences that we were just looking at for prisms and pyramids. So let's look at an example. For this example, we have a square pyramid. This is a square pyramid. And I know that it's a square because all of my lateral faces are congruent, which means that all of these are also congruent. So what shape is the base? It is a square. What's the height of the pyramid? Height goes straight from the top, from the vertex, straight down. So this is like when Indiana Jones lowers himself through the temple roof. He's like going straight down. This is falling straight through the roof of the pyramid. Okay, so the height here is 15 yards. What is the slant height? Well, the slant height is if I slide down the outside of the pyramid. Slant height is sliding down the outside of the pyramid. And in order to find that, I'm going to need to create that right triangle. And so we have this right triangle with the slant height and the height. And then this is going to be half of a side. So we have 15 here. Half of a side is 8. In order to find L, I need to do 15 squared plus 8 squared equals L squared. So I'll take the square root of those, put that into the calculator, and you should get 17. So the slant height is 17 yards. 17. Just by using the Pythagorean theorem, we can get that. Okay, so now we want to find the lateral area. Well, remember, this is dealing with triangles. So lateral area equals 1/2 perimeter times slant height. It's 1/2 base times height, base times height, base times height. So just like we were seeing with our polygons, the perimeter is to represent the added bases. If we go all the way around, we're adding up all the bases. So 1/2, the perimeter, 16 times 4, because I have 4 sides, each of them 16 yards long. Slant height we just found was 17. That's 1/2 times 64 times 17, giving us 544 square yards. Okay, next we want to find the base. Our base is a square. So the base is 16 times 16, which is 256 square yards. And lastly, we can find the surface area, lateral area plus one base this time, one base. That's 544 plus 256, giving us a grand total of 800 square yards. Okay, let's take a look at our next one. Now this one is, again, it is a pyramid, but it's a circular pyramid, so we call it a cone. My base here is a circle. What is the height? The height goes straight down, so that is 24 centimeters for the height. The slant height we're going to need to calculate. The slant height is the square root of 24 squared plus 7 squared into the calculator, and we get 25 centimeters. Again, just using Pythagorean theorem. In order to find the lateral area, this is a circle, so we're going to use 1/2 perimeter times slant height, where the perimeter is 2 pi r. 1/2 and 2 cancel out, that's pi rl. That's our simplified lateral area for a cone. Our radius is 7. Our slant height is 25. 7 times 25 is 175 pi squared centimeters. Don't forget your pi. Okay, to find the base is a circle. So that would be pi r squared. Our radius is still 7. 7 squared is 49 pi squared centimeters. Again, don't forget your pi. And finally, surface area, which is the lateral area, that's all the way around, plus one base, 175 pi plus 49 pi leaves us with 224 pi squared centimeters. Okay, let's look at our last page, which is more examples. So here we have, first I'm going to check it is a pyramid because it goes to a point. So this is a pyramid. That's going to be the 1/2. We've got triangles. It's going to involve 1/2. So our lateral area is 1/2 PL. I have L is 16. I have a side, which is 8. I don't have the height, but I don't need it quite yet. Okay, so lateral area is 1/2. Perimeter, that's 8 times 4. Lateral height, which is 16. We can put that into the calculator to get 256 units are square feet. To find the base is a square, so that's going to be 8 times 8, which is 64 square feet. It asks for the lateral and the surface area. I don't have to box the base. And finally, the surface area, which is lateral area plus how many bases? We have 1 for this problem. And so that is 256 plus 64, giving us a grand total of 320 square feet. For our next one, we have 1, 2, 3, 4, 5, 6. This is a hexagon, and it is a pyramid. Hexagonal pyramid. Okay, so pyramid means I'm using the 1/2 formula. Lateral area equals 1/2 PL. I have my lateral height here as 8. 4 is my side length. 2 root 3, it's this one here, is my apothem. How nice, they gave an apothem and a side, so it's going to be relatively easy to find the area. So 1/2, the perimeter is 4 times how many sides? There are 6, times lateral, which is 8. We can put that directly into the calculator to find 96 units are squared meters. Our base is a hexagon, so we use 1/2 AP, where my apothem is 2 root 3. And the perimeter we said is 4 times 6, same perimeter as before. Put that into the calculator, we get 24 times the square root of 3 squared meters. Finally, we have enough information for our surface area, which is lateral area plus how many bases do we have? Just one. So that's 96 plus 24 times the square root of 3. All of that is squared meters. If you wanted to round that, so if it says round to 1 decimal place or approximate to 1 decimal place, then we would put that whole thing in here, 96 plus 24 times the square root of 3, and we get 137.6 square meters. So again, you have to read the instructions, read the blueprint, read the instructions at the beginning of every problem, read carefully. In our next example, we're looking at a cone. I'd like you to try this. We've seen a couple examples so far. One of them was a cone. So for this one, we have, what formula do we use? Well, really, it's the same formula as we use for a pyramid. So lateral area equals 1/2 PL. But remember, this is the one that actually can be simplified because our perimeter is a circumference. 1/2 times 2 pi r times L cancels out. So pi RL is our shortcut. This is our shortcut formula for a cone. So that's pi times our radius is half of our diameter. So that is 3 times our lateral height we need to calculate. So here we have a triangle, 9, 3, L is my hypotenuse. And so L equals the square root of 9 squared plus 3 squared. If we put that into the calculator, we get the square root of 90, which is 3 times the square root of 10. 3 times the square root of 10. And so we get 3 times 3 is 9 pi times the square root of 10. And our units are square yards. Area of the base, again, this is a circle, so that's pi r squared. Our radius was 3, so that's 9 pi square yards. Now we can find the surface area, which is the lateral area plus we have one base. So that is 9 pi times the square root of 10 plus 9 pi square yards. For number 4, it's very, very similar. We have here a diameter of 10, so we have a radius of 5. We have a height of 13, which means we need to find the slant height. The square root of 13 squared plus 10 squared, leaving us a square root of 194. Doesn't simplify. So lateral area equals pi RL. Radius is 5. Slant height is square root of 194. Can't simplify that. 5 times pi times the square root of 194. We usually put pi after our numbers, so we'll put number, pi, square root very last. Units are square feet. And then the base is a circle, that's pi r squared, where the radius is 5. So that's 25 pi square feet. And finally, surface area, which is the lateral area plus one base. So that's 5 pi times the square root of 194 plus 25 pi square feet. If I was estimating it, I would put that whole thing into my calculator. 5 pi times the square root of 194 plus 25 pi, giving us 297.3. So we could say that is approximately 297.3 square feet if it is asking for an estimate or a rounding. All right, last two for the video. Here we have, now be careful because this is not a pyramid. There's no point that all of the sides go to. We have two flat sides. This is a prism. So our lateral area is PH, or 2 pi r because it's a circle. So diameter is 16, radius is 8, height is 6. 2 pi times my radius, which is 8, times my height, which is 6, leaves us with 96 pi squared centimeters. And then we have our base, which is a circle, pi r squared, radius is 8, giving us 64 pi squared centimeters. And finally, surface area, which is our lateral area plus 1, 2 bases. So that's 96 pi plus 2 times 64 pi, leaving us with 224 pi squared centimeters. And lastly, here we have a prism or pyramid. It has corners, but it doesn't have a vertex that all of the sides converge to. You can also say it has 2 flat sides here. So that is a prism. Lateral area is PH. Perimeter, so if this side is 49, then this side is also 49. So the perimeter is 23 plus 35 plus 49, giving us a perimeter of 107. And this is our height. 107 times 22 gives us a lateral area of 2,354 squared centimeters. Our bases are triangles, that's 1/2 BH. Do we have a perpendicular distance? Yes, we have 49. This one here is 49, which is perpendicular to 15. So that's 1/2, 49, and 15. Into the calculator, that gives us 735 halves squared centimeters. Leaving it as a fraction because I know I'm going to multiply it anyway. Surface area is lateral area plus how many bases? 2 of them. 2354 plus 2 times 735 halves. Cancel, cancel. 2,354 plus 735 gives us a grand total of 3,089 squared centimeters. Okay, if you've been following along and not really typing things into your calculator, it is very important that you practice typing these into your calculator. Because if you don't practice, then when you get to the test and you don't have any guidance on how to type them into your calculator, it will be a new experience, and you don't want anything on a test to be a new experience. All right, so if you didn't practice as we were going through the notes, go back and practice a couple of them, typing them into your calculator, because it is a little bit awkward at first. When do I type pi? When do I type the square roots? How are we carrying those over? One of the biggest errors on the test was dropping pi. You would do all the work right on your paper and then typing in the answer, there was just no pi. Pi was nowhere to be found. And so we really, really, really want to practice that. Okay, and then we'll see you in class. Okay, remember how I said any regular polygon could be one of our bases? This time we have a regular octagon. So here's one octagon. Here is another octagon. Those are our bases. That leaves our height as 22. That means our area of a base is going to be a little bit more complicated. But let's start with lateral area. Perimeter times height. Our perimeter, we have 1, 2, 3, 4, 5, 6, 7, 8. Says octagon, I confirmed it has 8 sides. So perimeter is going to be 5 times 8 times our height of 22. 40 times 22 is 880. Units are squared centimeters. And then we need the area of the base. Well, this is a regular polygon, so our area for the base is 1/2 AP, meaning we need to find our apothem. Well, if I'm looking at this octagon here, we can call that the center. There's my triangle that I need to cut out. So, draw this triangle. This is 360 divided by 8. which is 45 degrees, and then divide that by 2, which is 22.5 degrees. And then we know our side length was 5, so this is half of that, is 2.5 centimeters. Half because, remember, I make a central angle and then I cut it in half by the apothem. So this is my apothem, this is my radius, this is half of the side. Okay, how do I find A? Well, I have one angle and one side length. We need trigonometry. So in order to find A, I'm going to use, I don't have the hypotenuse, I'm going to use tangent. So A equals, sorry, let me set this up the way we did it in class before. Tangent of the angle 22.5, TOA, opposite over adjacent, that's 2.5 over A. That means, using our proportion trick, A equals 2.5 divided by tangent of 22.5. Now you can estimate that in your calculator, but again, we want this as exact as possible. And so if you calculate that in your calculator, you want to store it and continue to use that exact value. Okay, so this is approximately, if I put this in the calculator, 2.5 divided by tangent of 22.5, 6.03 or 6.04. But I'm not going to estimate that. I'm going to actually use A each time. So 1/2 my exact value of A times the perimeter. We already calculated the perimeter before, it was 40. So that is 20A. Now, why am I leaving it as 20A? I'd like to take this exact value times 20. So I'm not going to round it. I'm not going to estimate it. I'm going to take the exact value times 20 is 120.7. So I'm going to say that is about 120.7. But again, I'm not going to clear my calculator because I want to use that exact value when I'm finding the surface area. Surface area is lateral area plus 2 bases. The lateral area was 880 plus 2 times about 120.7. So I'm going to take that exact value again, times 2, that gives me my 2 bases, plus 880, that will give me my surface area. Now, the very last step is to round. If I rounded at the beginning, if I rounded here, and then I rounded here, and then I round here again, by the time I get to the end, I could have a very different answer. It could be off by a whole point or two. And we want to get as close to exact as possible. So try not to round until the very end. And so here I'm going to round to 1 decimal place. That is 1,121.4. 1121.4. And this is an area, so that is squared centimeters.